This problem demos chapter, or problem 7 from chapter 3. And in that problem, a relative has said they are going to leave you some money, and it'll be worth $30,000 in, let's say, 15 years. And the question is, how much would you have in the account today if it's going to be worth $30,000 in 15 years, and let's say the rate is 7%. We can use the same equation that we've used for the other problems that I've demoed via video, and that's the future value equals present value times 1 plus I to the n. In this particular case, we know the future value is 30,000. What we don't know is the present value, but we do know the rate is 7%, so I'm going to convert it to a decimal and add it to 1. And we know the time is 15 years. So I'm going to pop over to my calculator, maybe, and crunch that. So it was 1.07 to the power of 15, so 2.759. is this particular value that I'm circling right now. And this term has a name. It's called an interest factor. So the interest factor is 2.759. And then I'm just going to pull that 30,000 down. Now I'm going to divide both sides by that interest factor. And that should give me the present value. So the 30,000 divided by 2.579, or 759, gives me 10,873.5. So the value in today's dollars is about $11,000. If it stays deposited in an account earning 7% a year, it should be worth $30,000 in 15 years. So we already know the answer, but I want to show you another way of doing it. Several different ways of doing it. What I'm going to do is just take this equation and rewrite it. So future value equals present value times the interest factor at a rate of 7% and a time period, or an N, of 15. There are interest factor tables. There's some in your book. You can find them online. There are actually entire books of nothing but interest factor tables. And interest factors were quite helpful years ago, before financial calculators existed or before regular calculators existed. So if I look up the interest factor for the 7% rate in the 15-year time period, I can basically input my future value in that interest factor and solve for the present value. Well, on the Blackboard website, I've got a ton of stuff open. I've got to find it. Let's see. On the Blackboard website, if you go down to interest factors, I've created an interest factor generator. I've also created some tables that have different interest factors, and I'm going to use the tables to show you in this particular case. We are using the future value equation, so we need the future value interest factor. You can see there are 4 different interest factor tables: 2 for annuities, present and future value, and 2 for single sums, present and future value. Again, I'm using the future value formula, so I'm going to look up the future value of a single sum interest factor. So if you, I think I went in a bit too far. If you go over to 7% and down to an N of 15, you'll find the right interest factor, 2.759. And that should sound familiar. So here's the 2.759 is my interest factor. Multiply it by the present value, and then set it equal to the future value, which is the 30,000. And you'll see that gives me the same thing that we had a moment ago. It's just that I didn't have to calculate the interest factor like I actually did for the first time. I looked it up in a table. So then you just, again, divide both sides by that interest factor, and that would give you your present value. I could use the present value equation instead to solve this, and the formula is present value equals future value divided by 1 plus I to the n. Or I could write it this way: present value equals future value times 1 divided by 1 plus I to the n. If that's the case, if I opt to go this way, the value that I just circled is the present value interest factor of a single sum. So I could go present value equals 30,000, and I could either plug in the I of 7% and the n of 15, or I can pop over to my interest factor tables. Not this one though, because this is the future value interest factor table. I would go back to the present value of a single sum interest factor, go across to an I of 7 down to an n of 15 and find the interest factor of 0.3624, and that goes right here. Then if I take the 30,000 and multiply it by the 0.3624, so 0.3624 times the 30,000 gives me 10,872. Which is hopefully very close to what we got the first time we did it. The reason I'm off by $1.50 is because I rounded. This interest factor is rounded. If I had carried it out more decimal places, I would have gotten a more accurate answer. Now I can also do this on a financial calculator. So if I go over to the e-text, I go over to Chapter Resources, and then the Interactive Financial Calculator, scroll down to the bottom, or the second entry from the bottom to my time value of money calculator, and then input the rate is 7, and the number of time periods is 15. The future value is the 30,000. There's no payment. And then I don't actually have to click on the present value. I don't have to put my cursor in the input box. I just need to click on the present value. And there's the 10,873. And again, because I input a positive number here as my future value, it's going to return a negative value as my answer.